Hello everyone, welcome back. In this video, we're going to be looking at a proof that says if the inverse of a matrix A exists, then there can be no non-zero y for which the product of the matrix and that y is equal to 0. This is exercise 1.24 if you're using Watkins. This can also be found in any linear algebra book as well sometimes. So let's see. We're going to prove this one directly, so we're going to assume that the inverse exists, and then we're going to work our way to show that y must be 0. Like the only way that this product is true, only way that this is true is if y is 0, because that's what they're asking. They're saying show that there can be no non-zero y for which a times y is equal to 0. So that means that there is no value of y other than 0 that'll make this true. Right? It can get confusing. You just gotta slow it down and read it a couple of times, and it should make sense. But let's get started. So we're gonna assume that A inverse exists. So proof. Assume A inverse exists. Since A inverse exists, that means that A times A inverse, right, gives you the identity. This also works the other way around. So this also works if you have A -1 times A equals I. That's just the definition of an inverse. That if you multiply a matrix times its inverse, you get the identity. Here we are saying that it exists, so therefore the identity must exist. So we assume that it exists. Next thing, we start off with the information that we are given. So we are given that A y is equal to 0. But since we know that the inverse exists, we can use the inverse. Let's multiply the left side by the inverse. So we're going to multiply on the left side by A times -1. So it's going to be A inverse, not -1, just A inverse. And we have A y equals, and then as mentioned before, we have the inverse on the left side. Again, we multiply things out, but we know that A inverse times A is the identity, so that's going to give us just the identity and the vector, and that's going to be equal to 0, right? Let's fix that a little bit. That's going to be 0. Anything times 0, the vector will give you 0, and then the identity times anything will give you that which you are multiplying back. So the vector is equal, y is equal to 0. So that's about it. We have proven that if the inverse exists, then if we apply the inverse to our given statement, then after multiplying the inverse on both sides, we end up with just y has to be equal to 0. This forces the vector y to be equal to 0. So it is true that if the inverse exists, there is no non-zero y for which A times y is equal to 0. See, the only way this can be true is if y is equal to 0. So it can't be any other non-zero. So hope that helps out. Again, if you like this video, make sure to subscribe and like the video as well. Again, since we proved it.